With today's infrastructural technologies, China is on par with countries like the United States and Japan when it comes to development. Because of its extensive and well-developed infrastructure, China is widely regarded as a rising global force. You can't help but be awestruck whenever China takes over an infrastructure project. The new spectacular underwater tunnel constructed by Chinese engineers has stunned the world. All of the technology is made in China, and its price-performance ratio is superior to that of Europe and the US. This video will show you how Chinese engineers shocked the world by building this underwater tunnel. You'll be amazed at what could be accomplished with the correct technology and ingenuity. Let's go! It's becoming increasingly difficult for other nations to accept China's status as a growing country because of its reputation as an infrastructure madman, which has become China's most eye-catching business card. The country's largest underwater tunnel, built over 4 years at the cost of several $1 billion, has finally opened in China, allowing for 20-kilometer travel on a 6-lane highway 10 meters below a lake near Shanghai. As the longest underwater tunnel in China, this project is a significant technological feat. The 6-lane highway, which runs beneath Lake Taihu in Shanghai and is the country's longest underwater roadway, is exactly 1,079 kilometers long. The Røyfast tunnel in Norway is about 3 kilometers longer, but the Lake Taihu tunnel is wider. Those traveling from Shanghai to Nanjing, Jiangsu's capital, can now take advantage of an alternative highway. Driver fatigue has been reduced thanks to the installation of multicolored LED lighting on the tunnel's ceiling. Most impressively, the project was finished in only 20 years thanks to novel procedures for waterproofing the tunnel and the deployment of fearsome instruments to dig up to 4 meters beneath the lake. Construction site manager Wang Tongzhu noted that the 16-meter-long excavator used for the tunnel is totally Chinese-made and that foreign-made tunneling gear will no longer be necessary for China. On the other hand, China is currently engaged in a wide range of infrastructure projects. Another one is the country's longest tunnel, which is being built in the suburbs of Beijing. Even though China's high-speed rail network is one of the most extensive in the world, there is no sign of it slowing down. Beijing may be looking to the future as its network reaches the farthest regions of its country. For China, the goal is to build a train that travels from mainland China up through Siberia in eastern Russia, through the Bering Strait into Alaska, across the mountainous peaks of Canada's Yukon and British Columbia's Yukon Territory, and into the United States via the Bering Sea. They might expand their worldwide bullet train to every corner of the United States once it is built. So is there a price to pay for such a crazy idea? A staggering $200 billion. The plans first surfaced in 2014 when the Beijing Times published an article outlining China's plans to create the 8,000-mile super railway. The railway would be called China-Russia-Canada-America. Isn't it clever? It will also stretch over all 4 countries, allowing for more trade, tourism, and economic growth. To span the Bering Strait, an undersea tunnel 4 times the size of the Channel Tunnel would be required, as well as a level of technology well beyond that of the Channel Tunnel. China's engineers had claimed to be in contact with Russian counterparts about establishing a direct connection, which they believed was feasible given the state of the technology at the time. Despite how ridiculous the idea may seem, it could be a reality. With approval from the Chinese government in 2018, a nationwide network of underwater bullet trains was permitted, connecting the port city of Shanghai with the island archipelago of Zhejiang on China's east coast. The new route will include a 16.2-kilometer underwater portion as part of a 77-kilometer, 47.8-mile stretch of the nearly wholly new railway. Using a magnetic track, the train would levitate as it travels at high speeds, and development is already begun. With a bullet train traveling through, this tunnel faces unique construction issues that were not present in the Channel Tunnel. Ningbo-Zhoushan may be a test run for the China-Russia-Canada-America line, some have speculated, but nothing is known about the project's progress. Another is a 123-kilometer-long tunnel beneath the Bohai Sea, considerably larger than the one in Shanghai. Engineers in China may soon begin boring the world's longest submarine tunnel beneath the Bohai Sea, estimated at 76 miles, 123 kilometers in total length. It would be longer than both the Sican Tunnel and the Channel Tunnel, the 2 longest underwater tunnels on Earth. Engineers will have to tunnel between two fault zones responsible for a number of devastating earthquakes in the last century to connect the thriving northern ports of Dalian and Yantai, and it will cost $42.4 billion to complete. Dalian and Yantai are only 105 miles away by road, yet the journey takes between 7 and 8 hours. That might be cut down to a half hour with the Bohai Tunnel. With China's northern Rust Belt region and the wealthy eastern coast connected by a new tunnel, Shandong and Liaoning provincial leaders believe the tunnel will boost economic growth. In comparison to other submarine tunnels throughout the world, however, this one is a huge undertaking. The 76-mile length of the Bohai Tunnel would put it in the same league as Japan's Seikan Tunnel, which connects Hokkaido and Honshu, and the Channel Tunnel, known as the Channel. An extensive geographic survey must take place before the tunnel can be built. Chinese engineers, it turns out, have some expertise with underwater tunnels. The Jiaozhou Bay Tunnel, which connects Qingdao and Huangdao, was finished in 2011, as did the Xiamen Tunnel in 2010 and the previously mentioned 20-kilometer 6-lane roadway that runs beneath Lake Taihu near Shanghai. The cut-and-cover method was utilized in some of these projects, which is a standard technique for building an underwater tunnel. In this case, a trench is dredged in the ocean floor and parts of steel or concrete are inserted into it. The water is pumped out of the resulting route, and the rock is placed on top of the tube's upper half once the sections have been connected and sealed by divers. Since Bohai Bay and Jiaozhou Bay have similar depths, a cut-and-cover strategy might work. As compared to the Jiaozhou Tunnel, the Bohai Tunnel is 20 times longer. More advanced and expensive technology may be needed for the Bohai Tunnel than was employed in China's earlier undersea tunnels. This can be done if the seafloor is soft enough to allow for the use of large drills called tunnel boring machines, TBMs. These things are massive in every way imaginable. When it comes to the Channel Tunnel, or Channel, the TBMs utilized were 2 football fields long and could drill 250 feet every day. Because of the way it operates, 2 TBMs on opposite sides of the canal gouge through the sea floor until they meet at the center. When compared to the 75-meter depth of the Channel Tunnel's deepest point below sea level, the Seikan Tunnel's deepest point is 240 meters, making things more difficult for Japanese engineers. However, depth isn't the only thing that matters. TBMs can be risky and useless if the rock hardness changes a lot. Even though the Japanese attempted to use TBMs, they were forced to switch to 2,800 tons of dynamite due to the varying type of rock in the seabed. The procedure is known as drill and blast. On the whole, this strategy is riskier than the other two. Many leaks occurred during the Seikan Tunnel construction, one of which resulted in financial losses and the deaths of 4 workers. When workmen blasted into softer rock, they caused water to flood the tunnel at an 80-ton-per-minute rate, causing significant damage. For what it's worth, the drill and blast procedure was utilized in both of China's prior undersea tunnels. To be able to resist earthquakes of a magnitude of 8 or higher, the Bohai Tunnel will have to deal with 2 significant fault zones, not just depth and length. The Tanlu and Zhangjiakou Penglai fault zones in modern China have been the cause of constant seismic activity. At least 250,000 to 650,000 people perished in the Tangshan earthquake of 1976, but there have been many others. The 7.4 magnitude quake that struck under the bay in 1969 is perhaps the most worrisome historical earthquake for the tunnel engineers to consider. What's the best course of action? An oceanography professor at China's Ocean University of China, Li Sangzong, said that the solution was to strengthen the tunnel walls so they could resist an earthquake with a magnitude of 8. It will cost a lot of money to protect a big undersea tunnel against the kinds of earthquakes that have brought down entire cities. Shandong and Liaoning are reportedly contributing $16.3 billion in total. However, the price is already out of their reach because these tunnels usually always exceed budget. Examples include the Channel and the Seikan. The timing is a little difficult because of the high price tag of the tunnel, but since Bohai Tunnel isn't just a useless vanity project, its completion will be the best in the world, and it will even serve as a useful learning experience for the nation. Let us know what you think about all of these incredible underwater tunnels and their potential in the comments section below.